Let's look at how you can graph a piecewise defined function. A piecewise gets its name because it literally is defined in pieces. It tells you if your x value is less than or equal to 1, we want you to use x squared. If your x value is between 1 and 2, we want you to use 3. And if your x value is greater than 2, then we want you to use x. All right, so if I am going to graph that, then I'm going to start with x squared. All right, so if I graph x squared, that's the parabola starting at 0, 0. And it goes through 1, 1, and 2, 4, negative 1, 1, negative 2, 4. There's my parabola. It tells me that I only want to use that for where x is less than or equal to 1. So right here is where x is equal to 1, and then all the way over here is where it's less than. So I'm going to only keep that piece, and then I'm going to erase off the rest of the graph. All right, now let's look at the next one. So for the next one, it says between 1 and 2, we want you to graph y equals 3. What does the graph of y equals 3 look like? Well, that's a horizontal line at 3, right? So let's graph that. And we only want to keep the piece of that between 1 and 2. So we can look at that and say, okay, between 1 and 2 would just be this portion right here. Now, how do I know whether to use open dots or closed dots? Well, if you'll notice with the red graph of x squared, it said if x is less than or equal to 1. So we have a closed dot down here at 1. But see how x is just greater than 1 here? We have an open dot at 1 here because it can't be two different values. When you plug in 1, you can't get two different answers. All right, and so then when x is equal to 2 tells us to put a closed dot right here at 2. So we're going to keep just that little portion of the graph and we're going to erase off the rest of it. All right, then for the last one, y equals x, that is our identity function. That's the one that runs through 0, 0, 1, 1, 2, 2, 3, 3, negative 1, negative 1, negative 2, that diagonal line. And we are supposed to keep the piece of that that is greater than 2. So right here is where x is equal to 2. And so where it's greater than 2 are going to be all these values over here to the right. So I am only going to keep that portion of the graph from 2 on. Additionally, because it's greater than, I'm going to use an open dot there. So that would be the graph of my piecewise. All right, now if they ask me to find some values, let's say they want me to find f of 4. All right, there are two ways I could do this. To begin with, let's find it from the equations. All right, so f of 4, I'm not going to plug 4 into all three of these pieces. I'm only going to plug it into the piece that it is defined by. What I mean by that is if x is equal to 4, is 4 less than or equal to 1? Is it between 1 and 2? Or is it greater than 2? Well, 4 is greater than 2, so that lets me know I'm supposed to use the green piece. I'm supposed to use f of x is equal to x for my equation. All right, so if f of x is equal to x, then what does f of 4 tell me to do? Well, f of 4 tells me to put 4 in the place of x. So I'm going to put 4 in the place of x, and I'm going to get 4. Now, if you come over here and you look at this graph, when x is equal to 4, y is equal to 4. So graphically, we're getting the same answer as we did algebraically. All right, look at another one of those, f of negative 1. So which piece would I use for negative 1? Is negative 1 less than or equal to 1? Is it between 1 and 2, or is it greater than 2? Well, negative 1 is less than or equal to 1. So that means that I'm going to use the red equation, x squared. So f of x is equal to x squared. All right, they told me to find f of negative 1. So remember that means put negative 1 in the place of x in the function. So I'm going to put negative 1 in the place of x, and that would be negative 1 squared or positive 1. And so sure enough, if I come over here to negative 1, positive 1, there it is right there. So again, algebraically and graphically, I'm getting the same answer. All right, then for the next one, f of 2, which piece am I going to use for that? Well, you can see right here it says when x equals 2, I'm supposed to use the blue piece. So the blue graph was y is equal to 3. So remember, if y is equal to 3, it doesn't matter what x is. If x is 1, I get 3. If x is 2, I get 3. If x is 3, I get 3, right? If you're graphing y equals 3 for the whole real number line. So if I have f of 2, that tells me to use the function y is equal to 3. And so when x is equal to 2, y is equal to 3. And so sure enough, if I come over here, when x is equal to 2, y is equal to 3.